Welcome to another Beyond the Woods devlog, a software side look at creating an indie arcade game with the Godot Engine. Today we're looking under the hood of the animated font system I created to hopefully inform and inspire you to create your own for your game projects. I've been using this free horror font called Schlop for a lot of the text in this game, and I've thought for a while it would be cool if it could drip. Then I thought of all the animation work involved and backburnered it. But now, with the Midwest Gaming Classic rapidly approaching, I'm under the gun to get some UX things improved, and the animated font system came off the back burner and onto the plate. One of my design goals for this game is to hand animate everything as much as possible. I use Inkscape for this task. I know many artists prefer paint programs for their work, but I prefer vector graphics because it enables you to recycle and repurpose your work with minimal effort. Plus, the workflow feels a little more like sculpting than drawing, and that works out a little better for me. So I typed out each character in the Schlop font and then convert it to a path. This will be the first frame in the series. After tweaking it for legibility and simplicity, it gets copy-pasted into a new layer for the next frame. There are 5 keyframes which outline the main movements of the animation, and 5 tweens for smoothing. I do the keyframes first, copying the finished frame from one layer into the next and then modifying it. Then I repeat the process with the tweens. There are 3 animation passes done on each character. This simplifies the process. If you try to animate everything on each frame, it gets complicated quickly and you can forget to do things. The first pass is for the drip action, the second is for the pulsing movement, and the third is for the highlight. I do the graphics in grayscale so that they can be colored in the engine for different purposes. The pulsing pass goes pretty quick because the frames are all established. I tried to make each character pulse in a different way that emphasizes its shape. For the highlight pass, you just duplicate the whole image onto itself, turn off the stroke, and change the fill to white. Then shape it to suit the frame. Rinse, repeat. Each of the characters is an animated sprite node with our newly created sprites loaded. These are 15 frames per second. I actually got a twofer with these images, the full drip animation and a more subtle pulse animation just using the first 5 frames back and forth in a loop. At first it will take some back and forth between the engine and the art software to hone in on your animation. But once you get it down, you'll be a well-oiled animating machine ready to plow through the next 40 or so sprites you'll need for a basic character set. It took me a couple of weeks to complete this task, working a few hours a day on it. Make sure that you create a blank PNG image the size of the rest of your sprites. You'll need this to create a blank animated sprite for any blanks that may appear in your text. Once your character set sprites are ready, the coding part of the project begins. Sure, you could just add the sprite nodes manually wherever you wanted to use them and call it a day. But I wanted the text to be dynamic like an actual font, so that you could use it for changing text on a score or something like that. So this is how it works. There's an animated font scene that contains a control node, an HBox container, and a label. The label's visibility is off. The script reads in text from either the label or through a defined variable and then iterates through it, identifying each character and matching it up with the appropriate sprite node as contained in this dictionary. The sprite is then instanced and entered into a center container instance and add childed into the scene's HBox container. If the text variable or label changes, the setText function can be called again to update the HBox. There is a reset text function that clears out the HBox before new text is added. Make sure that you use free rather than queue-free on the HBox children. Queue-free does not clear the HBox fast enough to smoothly update the text. I've created some additional features to help improve this process. There's an exported variable to input the font size and points, and then some logic to resize the sprites to that approximate size. Additionally, there's a function to accept a pattern name and apply a different pattern to the animation. Right now there are sync and rand patterns that synchronize or randomize the animations respectively. This is an extensible system for implementing other patterns in the future. There are also exported variables for the sprite's animation and the font itself, so that any new animated character sets can be used with this scene. Just add a new dictionary referencing the new sprite set and you're good to go. This is a very flexible system, and I've been surprised how easily it came together and worked. Anywhere the labels are used, you can instance this scene, make it local, and child the label to it. Turn off the visibility on the label and it just works. I'm sure you'll agree that animated fonts really add a lot of zazz to your project compared to their static counterparts. Just look at these examples. If you like this video, thumb us up and subscribe if you'd like to keep up on this and other projects coming from Vagabond Arcade. Additionally, if you would like to help support this channel, consider giving us a tip through Venmo. Or, if you live in or are planning on visiting the Greater Twin Cities area, consider booking an appointment at Vagabond Arcade, Western Wisconsin's premier retro arcade in beautiful downtown River Falls. Thank you for watching.